Hey everybody, what's going on? Walt here for OverKill Projects. We are in the process of moving here, as you can see by the empty bookshelves. And I took a break, checked my phone, and I got one of the rarest of rare things, math news. And now, while math news is not a big attention grabber on YouTube, I probably should not even make a video about it, it's one of these things that's going to be so big in the future looking back, that it really needs more attention. And now, in particular, this math news has to do with the, up until now, unproven ABC Conjecture. The big news is that they're finally going to publish a proof that's now 3 or 4 years old, but it's extremely contentious, and we'll kind of get into why in a moment. But first, I want to give you a little bit of background so that you can understand what the ABC Conjecture actually is. And before we get started, if you like what you see today, make sure that you hit the thumbs up button down below so that I know that you like the video. The subscribe button's down there if you wanted to get updates for future content. Talk to me down below in the comments. Check the description because I'm going to post some stuff down there. And yeah, so let's get to it. So the ABC Conjecture comes to us from a field of mathematics called number theory. And number theory deals with numbers, but specifically integer numbers, and even more specifically, prime numbers. Now, in case you don't know, a prime number is a number that is only divisible by itself and 1. And it turns out that every integer value has a unique prime factorization. So what that means is that there is one and only one way to write every integer as a product of prime numbers. And now we say that two integers are relatively prime if they don't have any of the same prime factors. So for example, like 9 and 26 are relatively prime because they don't share any prime factors, whereas 10 and 6 are not relatively prime because they each have 2 as a factor. Okay, so now we're in a place where I can actually tell you what the ABC Conjecture actually is. So imagine we have 3 integer values, A, B, and C, and they are all relatively prime to one another. And now a little bit further, let's say that A plus B equals C. On the other hand, take the distinct prime factors of A, B, and C, which means take only one of each prime factor if there's more than one. So if one of the numbers maybe has 4 as a factor, then that's 2 squared. We're only going to take the 2. And now multiply all of those distinct prime factors together and call that number D. Then the ABC Conjecture states that D is usually not much smaller than C. So now I'm going to put it another way that maybe makes a little bit more sense, but it requires a little bit more thought. Take a really small number, some number that's very close to 0, a real number, something like, 1/1,000,000th, and call your very small number epsilon. The ABC Conjecture says that for any epsilon that you give me greater than 0, no matter how small it is, then there are only a finite number of values A, B, and C that follow the rules we gave before, such that C is greater than D to the 1 plus epsilon. Okay, we just got pretty mathy there, but it's pretty easy to break down. What we're really saying is that if C is greater than D to the 1 plus epsilon, then we're saying that C is greater than D and a little bit more, because any number to the 1 is itself. And raising numbers to very small exponents give us numbers that are like really just barely more than 1. So D to the 1 plus epsilon is just like D and a little bit more. It's just like multiplying D by some number very close to 1, just a little bit more than 1. So the idea that there's only a finite number of values A, B, and C for which this holds tells you that there are tons of numbers, maybe infinitely many numbers, A, B, and C, for which this doesn't hold. And for this to not hold, we would be saying that C is less than or equal to D to the 1 plus epsilon. In other words, we're saying that for the most part, D is going to be very close to C. And it turns out that this is a very deep result. Now, I'm not going to get into just exactly how all these things are tied together, but there are so many results where if the ABC Conjecture was proved to be true, we would get for free a whole bunch of other theorems and conjectures that would just automatically be proven true. This happens a lot in mathematics. Sometimes it turns out that a whole bunch of different problems, sometimes even across different fields that different people are working on, can be formulated in such a way that by solving one master problem, we knock down all the other problems like dominoes. So the ABC conjecture is like that first big domino. If we knock that one over, a whole bunch more dominoes fall behind it. And now this is where it gets interesting and where it actually turns into news. In 2012, which is 8 years ago now, a guy by the name of Shinichi Mochizuki, I think I'm pronouncing that correctly, released a few papers that were massive in length, and they claimed to prove the ABC conjecture. The only problem is nobody could read them. This is not a rarity in mathematics. It actually turns out that even people working in the exact same field on the exact same sets of problems sometimes have a huge amount of difficulty communicating with one another because the way they work on problems is so radically different from one another. And so as a result, for very advanced problems and for very advanced proofs, there might only be a couple of people on the entire planet who can actually, understand one another, who can check one another's proofs. And of course, those people are working on other things as well. So, the amount of time between proof and the acceptance of a proof can be pretty dramatic. And now in this case, I think it took about 5 years for two other very important famous mathematicians to comb through Mochizuki's papers and actually give their thoughts on what he had proven. And they found that there's at least one major crucial step in his proof that they think is irreconcilable, that you cannot fix his papers in order to make a real proof of the ABC conjecture. And so as a result, for the most part, I think the mathematical community has rejected Mochizuki's proof. And so this is the way things have sat for a while. There's a few people in the Mochizuki camp who think that he might have gotten it right. And then there's, pretty much everyone else who thinks that no, he needs to go back and fix these problems. Now, Mochizuki himself writes in a very difficult style to understand. It's very sort of non-traditional. And so his arguments are very difficult even for experts to pick up on. So the interesting thing that has happened is that in our crazy world that's happening today, they have finally decided to publish his proof in a major mathematical journal. One of the problems with this is that he is actually one of the senior editors on that journal. This is not the first time that somebody who is an editor on a major journal has published one of their own papers in that journal. Of course, he wasn't one of the reviewers for his own paper, or you would hope he wasn't one of the reviewers for his own paper. And so there shouldn't be a lot of conflict there. But the fact that a lot of the mathematical community wants this thing cleaned up in order for, everyone to be able to understand why this should be accepted as a proof, and that's not happening before this publication, is kind of a huge deal. And this is really the first time that I can remember a major mathematical journal publishing a result, publishing a paper that is so widely refuted. The typical contention in math when something's published and there's some sort of problem is credit. It's usually, oh, who proved this thing first? It's not, is this thing even proved? And so if you're interested in, STEM fields in general, mathematics in particular, this is an interesting topic to keep an eye on. I think that it'll sort of be in and out of the news as people talk about it. I'll post the articles down below in the comments. I think like Nature and Scientific American and a few other places have published articles about it. It probably won't be long before like the Wall Street Journal and the New York Times pick it up. And I'll post some tweets down below from mathematicians, stuff like that, about what they think about this thing. Anyway, I think this video is already too long. I just wanted to sort of like quickly touch on this thing that I think is newsworthy, that people should probably pay attention to, and I find it really interesting. So yeah, so I hope you did too. And if you did, let me know by hitting the old thumbs up button down below. Down in the comments, say hey. The description, like I said, it's gonna have some stuff in it. Subscribe down there, the bell gives you alerts and all that good stuff. And I think that's it for today. I'm gonna get back to packing and I will see you next time.